For the Baja team, I am Marcus Decker.
And I'm Riley Spilby.
I'm Adam Cole. I'm Alan Cole. So Baja SAE is a college level design competition which consists of designing, building, and racing an off-road vehicle against colleges from all over the world. All the teams are set to follow the guidelines outlined in the Baja SAE rulebook. In the fall semester, we start by choosing components, making prototypes, and doing all of our CAD modeling of our vehicle design. In the spring semester, we get into the fabrication and building of our vehicle. This includes machining, welding, and then assembly of all the components. And then the competition is the fun part. This is where we get to travel and go race against all those other colleges and see how we hold up against them. This is a picture from this past summer. We went out to Oregon and raced out at a motocross track there. The competition is broken into both static and dynamic events. The static event consists of our cost evaluation, design evaluation, and our business presentation. The dynamic events are the acceleration test, the maneuverability, and then a traction event of some sort, whether that be a sled pull or a hill climb or rock crawl. And then the big one at the end, the last day of competition, is a 4-hour endurance race where you just do as many laps as you can in that 4 hours.
So the SDSU Baja team is the Desert Hare Off-Road. We are fairly new. It's only our 4th year competition. The previous 2 of which have been in Tennessee and then Oregon, where we scored 56 and 49. So a yearly timeline with the SAE deadlines. We have in the fall semester, like Alan said, we do a lot of design. For the SAE, we have the business report, which is just a big report. And the spring semester, we start to build the car. In SAE, we have the roll cage documentation, cost reduction, business presentation, and an online cost prototype. And then about 2 weeks, usually after the school year ends, we have competition. This year is in Williamsport, Pennsylvania, and it's going to be the 16th through 19th of May. So a quick team breakdown for the Baja card is basically 6 sub teams. We have frame, steering, drivetrain, ergonomics, suspension, and brakes. Our senior design project is focusing on the drivetrain. The major goals of our drivetrain are building a vehicle that seamlessly integrates with the rest of the sub teams and has a top speed of at least 40 miles per hour, which is almost double our previous car, which was 22 miles per hour. Then we are also going to be able to start and stop on 40-degree slopes, which helps with the hill climb. And for stretch goal, we have 150 feet in 4.5 seconds, which would put us in the top position for acceleration events.
So, as Riley said, we're focusing on the drivetrain. Here we have like a traditional drivetrain from a vehicle. The whole entire goal of the drivetrain is to take the power from motor, transmit it to the tire. This goes through a series of systems, which starts at the engine, goes to the transmission, through the transfer case, differentials, axles, and wheels. So we'll start with our motor. The Polar Command Pro 14, which every school uses the same exact motor without any modifications. It has an air restrictor on it, so it's actually around 10 horsepower. And by using the same motor, it levels the playing field for all the different colleges. After the motor, we move into the transmission, and we looked into a couple different types of transmissions. The first being a manual transmission, which the driver has to use the clutch input and gear selector to select the gear. Automatic and dual clutch, they're both automatic transmissions. The left here, we show what happens with the automatic. And then we have a CVT in the top right, which uses a series of 2 pulleys, which adjust based off the vehicle speed and driver input to have like infinite gear ratios. So here's our decision agency for our transmission. We have two versions of automatic transmissions on the left, and then the CVT and manual. We had a couple different comparison points. The big ones were size, weight, and performance. The CVT blew all the other ones out of the water with pretty much fours and everything. It's really lightweight and effective for our situation. So how do we know the CVT is going to work? We did a bunch of calculations, and this pretty much sums up the performance of it. So here we have the velocity versus, or the terminal velocity versus the slope of the hill we're going to be going up. On the left is the last year's vehicle, and you can see steepest slope will be able to go up is 27 degrees, and that's accurate from testing we did last year. We have two different CVTs we compared. The first one's Gauge Engineering CVT. This one's designed specifically for these types of Baja vehicles, and it reaches our 40 miles an hour on a flat slope and can go up about 47 degrees. And there's a drop off right there from the belt slip. It's not actually locked in at a gear ratio on those steeper slopes. We also looked into the Steam Industry CVT, which is this black line. See it goes all the way up to 60 degrees slope. You might be saying you won't be able to drive up a 60-degree slope. That's more simulating a rock or something where you have to pull straight up and climb up.
Now onto the transfer case. Transfer cases redirect power from the one engine input to two outputs, sending power from the front and back. On the left here, we have a traditional four-wheel drive transfer case, and on the right here is our design for this year. We're just going to be using a chain and sprocket system for lightweight and simplicity. Moving on to differentials. Differentials takes the power from the transfer case and shoots it out left and right to the tires. Features of differential or gear reduction with increased torque, and it also allows the wheel to turn at different speeds. We had to decide between different differential options. We purchase, modifying, purchase, building a custom differential, and using it all in one transaxle. Different criteria that we base it on. The highest weighted ones were weight, performance, size, and reliability. We had a close lead between the purchase, custom, and transactional. The transactions scored 4s in everything but size and weight, just too large for our application. It will also go off the center of gravity for our vehicle. Between the purchase and custom, we decided to go with the purchase option because of the reliability in that 4-hour endurance race. Now we needed to choose between different purchase differentials, cost, weight, performance, and electronics to choose which one we're going to go with, and AutoCAD the other. Moving on to axles or half shafts. On the left here, we have a traditional universal joint axle. They transmit a lot of vibrations from the wheels. They also operate at low angles, which is now what we want. In the middle is a straight axle. It's very robust, heavy, and for higher load ratings. It also requires special suspension, which is what we're not doing in this year's Baja vehicle. And then moving on to continuous velocity axles, CB axles. They fit our selected AutoCAD differentials. They also have a higher range of motion, and they won't transmit vibrations. And this year we decided that we were going to go with a wheel reduction to decrease inertia. Since inertia is resistance to acceleration, decreasing inertia will be very beneficial for us. going from 23-inch tire to and a 12-inch wheel down to a 20-inch tire and a 10-inch wheel. We reduced mass by around 44% and reduced the inertia by about 67%.
So here's a weight comparison between the different drivetrains. We evaluated all the drivetrain weights, even though we went through and decided on each component individually, because each of the components has various capabilities, and this is more of a level comparison between the four. Our old drivetrain came in at 320 pounds. The transaxle drivetrain came in at 269 pounds. Our custom gearbox drivetrain is the lightest one at 204 pounds, and the purchase differential option came in at 224 pounds. We're willing to take the hit on the 20 pounds going from a custom to the purchase differentials because of the reliability that manufactured parts provide us. So for our overall budget on our vehicle, it comes in at $7,600 for the entire drivetrain, including the engine, CVT, and all our rotating parts. So an overview of our drivetrain. We start with our engine, which then goes into our Team Industries CVT, which then is connected on a shaft to our chain reduction down to our primary drive shaft. The primary drive shaft connects both our front and rear differentials. We're using the AutoCAD differentials. And the power then is driven through the CV axles down to our 20-inch all-terrain tires. Any questions?
What is the tread like on the tires?
Why is the tread like that one?
Yeah, I just haven't seen a tread like that.
There are different tread styles. Just depends on which one you want. The other part, you see so much on traction. We run into traction problems. We will have to look into different tread styles, but previously we just ran on a Ford before we started slipping the tires with our horsepower.
So for your differential, you're planning on an open diff, or are you doing a limited slip?
So with the differentials that we chose, we're gonna have the capability of choosing between a lock differential, an open differential, or putting it in neutral, so we could run either a front wheel drive vehicle or a rear wheel drive vehicle, depending on what we need. The other questions?
How many of you have been team members before this year?
3 of us.
3, and so you're just getting all caught up and I knew that one of you had just joined, but I couldn't remember which one it was, so you have blended perfectly. So good job. And how many years have you guys been doing this?
This is my 3rd year.
My 3rd year as well.